You might think that the best way to show the resistance would be to print it on the resistor, and this is sometimes done. However, some resistors are too small, or they may be positioned with the value hidden. So a color coding system is used instead. Notice the 4 colored bands. First 3 bands from left tell us, if we know the code, that this is a 12,000 ohms resistor. The code works like this. The color band nearest the end tells us the first figure. In this case, it is brown, which stands for 1. The next band is red, which stands for 2. And the third band tells us how many zeros to add. Orange stands for 3, so 3 zeros. 12,000 ohms. The color of the body of the resistor has no meaning in this system and is simply chosen to be different from the colored bands. The color code is on the resistor color code card, and you should use the card until you have done it so often that you'll never get it wrong. Let's try a few more examples, keeping the color code in mind. This resistor is yellow for 4, green for 5, and orange for 3 zeros, 45,000 ohms. Now this one. Violet is for 7, white for 9, and brown for 10, 790 ohms. All right, one more. Gray is for 8, yellow is for 4, black is for no zeros, 84 ohms. There's another way of marking resistors using the same color code. In this case, the body color is the first figure, the tip color is the second figure, and the spot is the number of zeros. Remember, body, tip, spot. It's easy if you think of sizes. The body is bigger than the tip, which is bigger than the spot. Body, tip, spot. Let's try a few. Here we have body green, 5, tip red, 2, and spot blue, 6 zeros, 52 million ohms. Now this one. Body yellow, 4, tip brown, 1, spot black, no zeros, 41 ohms. Again, body violet, 7, tip white, 9, spot orange, 3 zeros, 79,000 ohms. And now a catch one. What do you make of this? Well, the body is certainly red, so that's 2. But the tip is also red, so that's another 2. And the spot must be red as well. So there are 2 zeros, 2,200 ohms. No problem, really. This method has not been used in the United States since 1945. There is also other information that can be shown by the color code. Often shown is a tolerance color, which tells us how accurately the color coding gives the resistance value. For example, this resistor is 100 ohms, and the gold band indicates that the tolerance, or accuracy, is plus or minus 5%. In other words, the resistance shown as 100 ohms may be anywhere between 95 ohms and 105 ohms. That is, 100 ohms plus or minus 5%. The tolerance colors shown as the fourth band are brown for plus or minus 1%, red for plus or minus 2%, gold for plus or minus 5%, and silver for plus or minus 10%. If no tolerance band is shown, the accuracy can be taken as plus or minus 20%, which is often accurate enough. Now, what can you make of this resistor? The color bands indicate a 3 for the first figure and a 3 for the second figure. But what is a gold doing as the third band? Well, when gold appears in the third band, it means take 1/10 of the resistance value indicated by the first two bands. So this resistor is 33/10. That is 3.3 ohms. If the third band is silver, you divide the indicated resistance by 100. In this case, 25 divided by 100, that is 0.25 ohms. So if you have a gold as the third band, take 1/10 of the value indicated by the first and second band. If you have silver as the third band, take 100. Some resistors are called precision resistors, which are printed with 1% tolerance and value in ohms. Some are also manufactured to particularly high standards. They are said to have high stability, and this is shown by a pink band, like this. So the color code on this resistor tells us that it is 64,000 ohms with a tolerance of plus or minus 10%, and it has high stability. So you can now learn a good deal simply from the way a resistor is colored, relying, if necessary, on your resistor color code card.